All right, class, welcome back. This is another concept in 8.6, which is just more graphing of quadratic functions. So this is another facet to that. And what we're going to do this time is we are going to find the max or the min of a quadratic function. Well, how do I know if it's going to have a max or a min? Well, it will have a max if the parabola opens downward. It could look like this. It could look like this. It could look like this, right? So again, it doesn't matter where this vertex is, you know, whether it's on the y-axis or in the negative or in the positive or whatever. If this parabola opens downward, then you will have a max. And the max value will always be the line that goes across here. In this case, it would be this line. And in this case, it would be this line right here. This is the max value. Well, the max value will be then at the y value of the vertex. It'll be at the y value of the vertex. So you will get y equals k. Okay, whatever the max value is of the vertex in this case. Won't always be equal to k, but we'll just call it k. Again, we'll look at this, but it'll always be equal to the y value of the vertex. All right, when will we have a min? Well, we will have a min if, or a minimum point, if we're looking at a parabola and it opens upward. If it opens upward, how else could this look? We could also have a min that looks like this. We could have a min that looks like this. Okay, and how do we know it's going to have a min? Well, we know it's going to have a min because it opens up, opens upward. And again, regardless of where this vertex is, whatever the vertex is, this is going to be the y value. Okay, so it'll be this line. The minimum value that it'll ever come to is the lowest that this will ever go is right here. And this is a horizontal line at y. Again, this will be that horizontal. It'll never go lower than this horizontal line. And in this case, it happens to be the x-axis. So again, we'll get a value of y equals k, whether it opens upward or downward, doesn't matter. It'll be the y value of the vertex. Okay, so again, if it's a max if it opens downward and a min if it opens upward. Well, how do we know if it opens upward or downward? Remember that we're going to be dealing with these two different forms. And here, if a, in both cases, right, these a's. All right, so what do we know? We know that if a is positive, then the graph opens upward. Okay, so if the value of a, whether we're talking about this a here or this a, regardless of which form it's in, if it's positive, then the parabola will open upward. Okay, well, what else do we know? We also know that if it's negative, if a is negative, then we will open down or downward. We'll put upward and downward. Okay, again, so if it's negative, then it's going to open downward. If it's positive, it's going to open upward. Great. So looking at this function, I could tell you right now this is going to open downward. And because it's going to open downward, we are going to have a max. But what is the max? Well, we're going to use our nifty, when it's in this format, we're going to use the Vertex formula that says that negative b over 2a is the x value, and the f of negative b over 2a is my y value. All right, so I'm going to plug this in. So in this case, this is negative 10 over 2 times a, which is a negative 1. So my x value then is going to be 5. All right, well then I also need to plug 5 in to my function. So the f of 5 is going to be equal to negative 5 squared plus 10 times 5 plus 5. So 5 squared is going to give me 25, but that's going to be negative because the negative's on the outside, plus this 50 plus 5. So I have 55 here minus 25 is going to give me 30. So the f of 5 is equal to 30. So this is the y value. So I get that my vertex is 5, 30. All right, so if this is the case, again, this is going to open upward, and we know the vertex is at 5, 30. We could say that this is every 5, 10, 15, 20, 25, 30. Then this vertex is right here. It opens upward. Then our min is going to be at this point right here. So it's going to be, the min value is y equals 30. That's the smallest that that will get. Okay, so again, we've got this min value here, kind of a super rough sketch of the graph. Again, this isn't asking you to graph, it's just asking you to find the max or the min. We know this is open downward. So looking at this next one, it's not in standard form, it's in vertex form. So we can just say that the vertex is HK. So we know here the vertex is HK. So that is going to be 2 and 4. Well, the coefficient here, there isn't one, so it's positive. So we know that this is going to open upward. So we're going to have a min here. And where's that min going to be? Well, what does this look like? Well, we're going to go to 1, 2, and 1, 2, 3, 4. Here's my vertex. And this opens upward. Okay, so this is going to be then at the value of y equals 4, or this y value right here. This parabola will never go below that. So our min is right here. I just realized that a second ago when we graphed, we had the points 5 and 30, but I accidentally opened upward. So what would that look like? Again, we've got 5, 10, 15, 20, 25, 30. It would be here and it would open downward. So I think I did that wrong. So here our max, it can't go any higher than this, is y equals 30 still. Okay. Hopefully I didn't totally screw that up. Again, this opened downward. We know this opened downward because it's negative. And all right, so this is finding the max or min. Again, you're going to have a max if it opens downward because it won't go above that point, and you're going to have a min if it opens upward.